Okay, now we start the easiest chapter in pre-cal, calculus. We're going to start with the introduction to limits. That's 12.1. And start with the definition. A limit of a function is the value that the function is approaching as x approaches some value c. Okay. To estimate it numerically, we would make a table of values on the left and on the right of the number c that we're looking for. So let's give one a try. Okay, the limit as x approaches 4 of 2x plus 1. So what you want to do is you want to fill in the table with values on the left-hand side and then on the right-hand side of 4. And I will let you do that. Pause for a second, and then I'll fill out mine. Okay, for mine, I chose 3.9, 3.99, and 3.999. So I'm getting very close to 4. And I get 8.8, 8.98, and 8.998. Now I could probably guess what it's going to be, but let's try it from the right. From the right, 4.1, 4.01, and 4.001. So getting very close to 4. And that gives me 9.2, 9.02, and 9.002. So as you can probably imagine, the value that they're approaching as x approaches 4 is 9. So we say the limit as x approaches 4 is 9. Now you're probably saying, Ms. Pointer, why would you do such a thing? Why can't I just plug in 4 and get 8 plus 1 is 9? Well, you can. And in fact, direct substitution is the easiest way to do a limit if you can do that. However, you'll find that we can't always do that. For example, let's look at the limit as x goes to 0 of x over the square root of x plus 1 minus 1. Now, you might think it was going to be 0, but then have a look again at the denominator. If we plug in 0, our denominator becomes 0, so that's not allowed. So we're going to have to work this with a table of values from the left and from the right of 0. So I'm going to stop here, you pause it, and then you pick out some numbers in your table. All right, now here's my table. I chose negative 0.1, negative 0.01, and negative 0.001 on the left. And on the right, I chose 0.1, 0.01, and of course 0.001. So creative that I am. All right, for negative 0.1, I got 1.95. For negative 0.01, I get 1.995. And 1.9995 for negative 0.001. And then, of course, over here we get 2.0005, 2.005, and 2.05. All right, so we can probably guess now that the limit as x approaches 0 of our function is going to be 2. Okay? So, graphically, you can also tell, because if I graph this function, x over the square root of x plus 1 minus 1, here's my graph. And you can tell as you get closer and closer to 0, this function is actually getting, the y value gets closer and closer to 2. And the value of the function is actually the y value, and that's what we're talking about. Right there, at 0, there's a hole. It doesn't exist. But the existence at the value doesn't matter. The only thing that matters is what happens as it approaches. So the limit can exist even if the value of the function does not exist at that point, which is always neat for limits. That's what it's getting close to. A limit can also fail to exist. The limit of f of x does not exist as x approaches c if you have the following situations. The value from the left-hand side is not the same as the value from the right-hand side. They don't meet. 2, the value of the function goes to infinity or negative infinity, because that doesn't have a value either. Or if the function oscillates around a given value of c. So if you look at it and it's just jumping, oscillating back and forth over the axis. So let's look at some graphs. All right, now you look at these graphs, try each one and tell me which reason above do they not exist. Okay, I'm going to pause here and put those in your calculator. All right, I'm back. And there's my graphs. And you can see the first one, the limit as x approaches 0. If we look from the left-hand side, we're going up, and I think this one is reason number 2. It goes to infinity, so it has no limit. We say the limit does not exist. On the second one, it's kind of hard to see, but there's the purple line here and the purple line here. You can see as we come into 0, they just don't meet up. So the left hand doesn't agree with the right hand, so that's why we have the limit does not exist at 0. And then the last one, and it's really neat if you take your calculator and you keep zooming in at 0 to see what's happening. You can watch the graph oscillate. It'll jump back and forth, back and forth, back and forth. No matter how much you zoom in, you can't ever see what's happening right at 0 because it keeps jumping back and forth. All right, some properties of limits. All right, let's say b and c are just numbers, and n is a positive number. And f and g are going to be functions. So let's look at the limits of different properties. The limit as x approaches c of b. Well, what does that mean? Well, the limit as x approaches c, b is a number. So think about that graph. That would be the graph y equals a number. That would be a horizontal line. What are all the values going to be for that? I think you'll see that's b. All right, so the limit as x approaches c of x, so that's the function y equals x. That's the line, y equals x. And if x is getting close to some value c, what's the y value have to be getting close to? That same value, c. All right, number 3 is a power function, x to the n. It could be any value, squared or cubed or anything like that. But there's not going to be, because x to the n is a nice polynomial, there's not going to be a place where it's undefined or it takes off to infinity. It doesn't have any vertical asymptotes, so we can just do a nice substitution. The limit as x approaches c of x to the n is c to whatever power the n is. And then finally, the last one, the roots. Well, the root is also a nice continuous function as long as you're on its domain. And so we can just substitute in. So this becomes the nth root of c, a nice easy substitution. All right. So let's say that the limit of the function f is some number f, and the limit of g is some number g. So we found those values, and we know what they are. So there's some interesting things about the addition and subtraction and all the different operations on the limits. Okay, the first one's a scalar multiple. Well, if I multiplied a number times the function 2 times g of x, guess what's going to happen to my limit? You're probably right. It's going to be doubled. So that's going to be 2 times whatever my number was before. What if I have I have these two functions, f and g, and I added or subtracted them? What's going to happen? Do I have to go through and work all of that out? Or can I, if I know it's one's f and one's g, I just say, okay, well, that's got to be f plus, if it's subtraction, minus g. I think you can probably guess what's going to be the product. F times g. And the quotient, f over g, provided g does not equal what value? Very good. And then finally, if we're raising the function to another power, instead of actually having to go through and multiply it out, I'd hate to take that second example we did and raise it to the third power, but I could just take my answer and raise it to whatever power I was given. Okay? So those are the properties of limits and using a table or a graph to find a limit. A lot of this is going to be on your calculator, so